Hi, welcome to our presentation. We will be looking at the dust in our air. So we're section 2, team 1. I'm Vivian.
I'm Haley.
I'm Garrick.
And I'm Domenico.
So to start off, the main focus of our experiment was to relate the dust density to temperature, humidity, and light. We did this by using 3 different sensors that were controlled and recorded using a microcontroller with an SD card logger. And then using this data, we then compared to the current models already out there. So the current models that we're comparing to are from different studies. These studies focus mainly on pollen. We couldn't really find anything about just like vaguely dust, so we decided to use pollen. And most of dust or outdoor dust is pollen, so that's why we are assuming that any fluctuations that we see will be from pollen. Additionally, from these studies, we can see that temperature has a direct relationship with the pollen amount, and relative humidity has an inverse relationship with the pollen density. Experimental procedures. So for our experiment, we had to have our sensors outdoors since we were looking at outdoor dust densities. And from our data sheets, we found that it would be the best to have it in direct sunlight and away from plants. Our testing period was 24 hours, and this started at 10 a.m. on April 23rd.
So the dust sensor that we used comes from Sharp. It uses a LED that it flashes periodically and a phototransistor that detects how much of that light has been scattered. We turn the output voltage into dust density in micrograms per meter cubed based on that equation in the on the left side. The light sensor we used was the photoresistor we received in the kit. We used a voltage divider to read out the resistance of the photoresistor, which changes based on a log-log scale with ambient light. We used the second equation in order to convert the resistance into lux. The temperature and humidity sensor we used was the HT11, which also came in the kit. It uses a thermistor to measure the temperature and a capacitive humidity sensor to measure the relative humidity, and rounds both to the nearest integer in degrees Celsius or relative humidity percent. The code that we got from the DHT11 open source code reads in data every 2 seconds. And so we use this to collect data from all of our sensors every 2 seconds for the entire 24-hour period.
So we collected data for dust and we plotted this against temperature, light level, and relative humidity. And we created a regression line and R-squared value using MATLAB. But unfortunately, some of the dust data was a little bit noisy, so we used MATLAB to smooth out the data. And the gray points are unsmooth and the blue points are the more smooth data points.
Right, so after we smoothed this data, we got the following dust versus time graphs. So again, our data was taken over a span of 24 hours. The most obvious variation in the dust throughout the day is seen in the bottom right, which is Vivian's dust, in that at the beginning of the day when it's light out, you can see that the dust is at its highest. In the middle, which is dark time or nighttime, you can see that it's at its lowest. And at the end, you can see it peaks when it comes back up to being daytime once again. And now we have temperature, light, and humidity. So here, blue is humidity, red is temperature, and black is the light. So these were all slightly different because of our different calibrations for our sensors. So what we did was we normalized them by dividing by the largest value. So these are as percent of the largest value. We found that the relationship between light and temperature was very similar, and that the relationship to our other values was also very similar. So we just made the assumption for this report that their relationships with each other would be the same, and that we're going to focus mainly on temperature's relationship with dust and humidity instead of focusing on both light and temperature. And here we have the dust versus temperature plots, which appear to be very similar to our predicted model, and that they all have positive correlation, and that 2 of our R values are actually very large compared to our previous predicted models.
And here we have plots of dust versus humidity, and like our predicted models, they also have a increase in dust as relative humidity decreases. And an overview of the entire experiment. is that experiments A and C consistently had a large R-squared value above 0.65. Experiment B consistently had low R-squared value below 0.1. And the R-squared value for our study was actually much higher than other studies. It was about 0.7 versus 0.3 and 0.5 for the other studies. And we attribute this mostly due to the data smoothing that we did.
So our experiment did have lots of variation, and so ways that we can prove about that is the standardization of location. So all 4 of the experiments were taken place in very different parts of California, and along with that, they took place in very different atmospheres and environments that have varying vegetation that causes different influxes of pollen throughout the day. So Vivian's had a large amount of pollen, and so therefore her change in pollen, or the delta throughout the day, was quite large compared to my own, which is on a 2nd-story porch, and so therefore had very little change in pollen throughout the day. We would also like to record longer periods of time and get more whole 24 hours of data so we can see a stronger correlation. And we would like to better calibrate our sensors so that we can see them, not have to normalize them against each other, and probably have less error.
Thank you very much. If you have any questions, please send them over via email.